I am very, very excited for this next panel. Good afternoon, everyone. My name is Dave Renson. I am a Google SRE running customer reliability engineering, and I'm super excited for us to have a conversation about some of the weird, wild, and just plain wacky things that we have seen over the last 10 or 11 years in Google SRE, and really excited to have the people joining us today. So welcome to the Fifth Nine. Settle in, enjoy your lunches and your beverages, and we're going to kick off. A little later, there'll be a little audience participation. I made some notes because I want to make sure my introductions are correct. So first, I would like to welcome George Sadlier to the stage. Come on up, George. George is a 10-year Googler. He has worked in about every corner of SRE you could imagine, from ads to BigQuery to Chrome to Dremel, which most of you will know externally as BigQuery, and we are honored to have him here next. Steve Cartensen. Steve, come on up. Steve runs network infrastructure SRE at Google. Basically, his team is responsible for the health of our production network. And, you know, when it catches fire, which occasionally it will do, they're the ones who run in to fix it. Our third panelist today, I thought would be fun, is John Welsh. John, come on up. John's done a bunch of things at Google, most notably working on cloud reliability. But the thing I think makes him most interesting for this is his other job, is he runs a thing called DIRT, Disaster Recovery Testing. So basically, Steve and George are responsible for fixing things and making sure things are operating right, you know, when they break and getting things back up and running. John's job is to proactively break things to make sure that we can respond in a reasonable way. I thought that might be kind of an interesting mix. So, if you'll please, a quick round of applause for our panelists, and we will kick off with some of this. George, I want to start with you. If that's okay, we'll just pass a mic around. I have a farmer's almanac in my house that I bought these many years ago when I was a kid. And in the front, it's got a set of things that every farmer knows is true. And one of them is that lightning never strikes twice in the same place. And what I want to know from you, George, is, were they full of it when they wrote that, or were they right?
I'm not sure what the science is on the matter. Unfortunately, observed evidence proves it to be a false. We've certainly experienced multiple. I'm being signaled to keep it closer to me. Okay, that better? Cool. We've certainly experienced multiple strikes in quick succession. We had a particular scenario in the last year in Belgium where we had actually, it was a half dozen strikes in fairly rapid succession over a couple of minutes, striking the electrical grid, supporting one of our facilities, which caused some interesting. I mean, obviously these facilities are designed to survive power loss, and so yeah, the grid went out and we went on to emergency power. But it was interesting because those systems sort of kicked in, carried the facility, went back off again because the power was restored, and then we went back onto emergency power, and then off, and then on, and then off, resulting in much drama and entertainment, mostly because I think we thought the systems were malfunctioning.
Cool, I'm good. Okay, so as I recall, right, there were a bunch of strikes up and down. It was us and the substation and the power provider and then back, and then like a kind of a ping-pongy thing. This is not a thing we planned for, right? There's no plausible computer model where that pattern of lightning strikes makes any sense, but still we muddled our way through it. Can you talk a little bit, just at a high level, about planning and the general principles of defense in depth, right, that let us survive what's frankly completely unpredictable sort of a thing?
Yeah, I mean, like any large-scale data center facility, we've got extensive backup power in place. You know, we've got standby generators ready to come on at no notice. We've got the battery backup systems to cover us during that transition. You know, we don't expect that type of scenario, but at the end of the day, any power outage is a power outage, and we were able to cover through it. Most of the drama in that particular instance was sort of unrelated to the multiple strikes, but more came down to a software glitch in our battery controllers, which caused a little bit more drama than we really needed that particular day, resulting in some loss of power to some racks, which we did not appreciate.
All right, Steve, let me ask you something. So the other day I was reading my most reliable internet conspiracy theory sites, because as we know, everything's very reliable on the internet. And I stumbled on something I thought maybe you could comment on. My understanding is that they actually make underwater fiber cables out of fish food. I wonder if you could tell me about that.
Sure, although it's not really fish food, and we don't really know why, but it is true that sharks do like to chew on the cables that we run the internet through, the networking through under the ocean. Google actually wraps its, well, according to stories I have read, I actually don't have personal knowledge here, Google has a patent on a fiber that or a fabric that we wrap around the cables, that we might wrap around the cables to protect them from shark attacks, but I don't know if we actually do that. That was a different internet company that that story was about. But we have a lot of animal-related outages of one form or another. Now, most of these don't actually cause outages. They just cause problems. We had a case in Atlanta a number of years ago where a snake got into the power, I believe it was a power transformer station, and shorted out part of the grid at that data center, which was exciting. We've had birds flying into transmission lines. We've had, in one case, a fiber that we leased in Brazil was cut by somebody who was digging a hole to bury a horse. We've had all sorts of fiber and network outages and power outages related to things.
Okay, so cat videos notwithstanding, animals are not always big fans of the internet, as it turns out.
They're one of the things you have to deal with.
All right, John, I've always wanted to ask you this in all the time I've known you. So your job, as I understand it, is to cause problems for production teams in production, to break things and either tell them ahead of time or not. What I want to know is, you're like the most popular person at Google, right? I mean, I assume you like eat alone, maybe under armed guard? How does that work?
I try to keep a low profile. But yeah, so we manage the disaster recovery testing program. We call it DIRT for short. And it's a program to, in a very controlled way, find issues within our systems, break them, and recover from them, right? And the recovery is obviously very important, and we always want to do this in a way that isn't customer-facing. So, we're always out there. We run continuously year-round, and then we have like these company-wide sort of disaster recovery testing week events.
And then without using names, because I don't want you to, tell me, in the world of cloud, right, the reliability is not just what we're offering, it's what our customers are bringing to it. Do we ever do dirt like with our customers? We've certainly done tests with other companies in a very, again, controlled way. Everything from looking at incident management, maybe you have an issue with your systems running on our cloud, and you need to escalate that in to Google support for cloud. And so how would we do that, and how do those issues go from your system, your product, through to our support, to our engineers, and get resolved? It's something we want to practice and make sure we have good and effective communication. We want to make sure that we can find issues with your systems that are, the software that you're relying on within the platform. Ali, where are you? Okay, so we have an audience, right? I thought maybe it'd be an interesting idea if we took questions. It's always a little, it's live, so who knows? We'll see what we get. If you want to ask a question about some of this stuff or other reliability things, just give a quick signal to Ali, and we can do that.
Sure.
Wow, a shy crowd. I do see we have in the crowd Bart Fromm, the mysterious and amazing Bart Fromm. Bart is the Director of Cloud Reliability for all of Google. Come on up here, Bart, so we can embarrass you a little bit.
So, why don't we talk about, I guess the one I think we should talk about from a dirt perspective is how large of scale we try and do the dirt tests out. Like, are they small tests? Are they large tests? Like give people a sense of like how thorough we go into that.
Yeah, sure, absolutely. So, thanks, Bart. So we run tests at a team level, right? So individual teams, but we also run them across large systems. For example, we have done tests where we power cycle a production data center. So this is, not like just hitting the restart button on the desktop under you. There's, lots of planning that goes into it, many complex systems that we have to plan mitigations and, try to understand the best way that we expect it to fail and be prepared. And so, of course, you can imagine all these services are running within the data center. We take a lot of precautions to make sure that they're out of the way and to make sure that SRE can rebalance that load of those services across the other data centers. At scale, I think that's one of the largest is shutting off an entire data center and turning it back on again. That's pretty large.
Steve, we were earlier talking about problems we run into with fiber. Can you sort of talk about the redundancy that we build into each building or into each campus so that we're not sort of stuck when a shark or a boat's anchor rips through one of our fiber lines?
Sure. So the way we design our network involves multiple paths between all of our points of presence and our YAWN data centers. So a single fiber cut should never cause us a problem, although, of course, there are exceptions. We provision the way that the networking is sort of sized to be resilient in the face of any individual component going offline, either within the data center or outside. This means that most of the time when we have fiber cuts, and we have fiber cuts all the time, no one notices. The most of the time when there is a customer visible or even just Google service visible outage, it's a result of 5 or 6 or 7 or 10 concurrent events, some fiber cuts, some router down, some other issues. And even in those cases, we've usually been able to recover service in advance of the systems that broke being put back into service by routing traffic better or in a more intelligent fashion.
Sorry, being told to move away from the speaker because I'm creating feedback. One last question around the network pieces. Obviously, we're a very large network. One of the things Eric's talked about was the size. Can you talk about how much we see with regards to when we get DOS attacked? Like how big of an issue it is that we feel like we get versus what actually ends up happening?
I can say that in the recent past, the majority of botnets that we are aware of do not cause Google services problems. We are pretty sure that there are larger botnets in the world that have not attacked us, so I don't want to say we are immune, because we are definitely not immune. But as far as we can tell, the DOS attacks we see in the wild, either directed to us or that we see backscatter from, we believe we would be able to cope with. And certainly the ones that actually have attacked us, we've been able to cope with quite well.
All right, let me shift here for a quick sec. George, you do a ton of reviews with teams. You do a ton of interviewing. In all the time that you looked at stuff, like if there was just one thing out of the canon of reliability principles that you wished everybody did, what is it?
Can we let Steve tell my favorite story first?
Okay, tell George's favorite story. I don't know what that is. What is it, Steve?
All right, so this is a story about a major outage we had a few years ago. It was actually not an outage. It's one of my favorite sort of outages. It was a near miss. We run, just a bit of background about the Google infrastructure. Most of our computers are in data centers, which are typically pretty far from where our users are. In order to improve the experience of Google customers, we run a large fleet of dedicated servers on the edge of our network that do load balancing, TCP termination, SSL termination, et cetera. This is all still within Google's network, all within Google's control, but out sort of in our points of peering at the edge of the network. So these edge nodes are different from our normal data centers, so they have their own set of automation, turn up, turn down, et cetera. And a couple of years ago, one of the engineers who was working on the turn up, turn down automation specifically for these edge nodes was exercising a new pathway, a new particular way of doing something. And he was mistakenly under the impression that the turn down automation was idempotent. That is, if you ran it twice on the same thing, nothing new would happen. Unfortunately, he was wrong. So first he ran it once, testing out a particular workflow, a particular step that sends all the machines in a particular edge node to something we call disk erase, which is when we erase all the disks as part of doing turn down. And that worked just fine. It was a satellite that was already going out of service. There was a bug with the workflow, so we ran it again on the same satellite. Unfortunately, the way that this actually worked is you say, I want to run this thing on this set of machines, and the way you get the set of machines, very briefly, is you basically say, I want all of the machines that fit this particular pattern. Unfortunately, the result of no machines match this pattern is not no machines, it's all machines. We have seen this failure many times in very, very different scenarios, but anytime you interpret an input as everything, you should really think carefully about what you're doing. Because of the layers here, no one really understood that this is the way that this would be interpreted. The upshot was this engineer accidentally called disk erase on every edge node in the fleet at the same time. Another funny, sort of, to me, side note is my team, who runs the edge nodes, didn't at that time believe disk erase worked on the edge nodes. Like, we just thought that it should work. We hadn't gotten it to work, we thought, and it was probably just wouldn't do anything. It turns out we were horribly, hilariously wrong. In the course of about 20 minutes, every edge node in the fleet lost its mind, lost all of its configs and binaries, and stopped serving. Now, you didn't hear about this because the way we design, the way we do front-end serving involves as seamless failover as we can. TCP connections were reset, so there was some spike of new connections being formed, but all of the traffic relatively seamlessly failed over to the back-end data centers where we have reserve capacity. There was also some congestion on our backbone and with our peers because of details of how we do BGP. When we terminate TCP connections in data centers versus our edge nodes, it changes where the bits egress from our network, and so some of our peers were congested, and we had to do various traffic engineering on our backbone in order to resolve that. But for the most part, no one noticed. No one noticed over the next 48 to 72 hours as my team put together basically everyone on the team into 2 12-hour shifts in the Bay Area and in London, trying very, very hard to put the edge back into place as fast as we could. We ran into all sorts of problems doing this, but again, and I can talk about those if somebody wanted me to, but the upshot is defense in depth is a very useful thing. No one noticed. We were really lucky that we found this out in this particular scenario. It turns out this exact piece of automation could have done the same thing to a different class of machines that would have been far, far, far worse. So in a way, we're really lucky we did it to the edge. And it was a tremendous, we had a tremendously awesome postmortem internally. It was a great bonding experience, I think, for the team. And it still is a story that we talk about because it's a very formative outage. Well, near miss.
And there are times, right, where defense in depth in a weird way is not your friend unless it's accompanied by testing. And I recall we had an incident where, we've talked about this publicly, where we pushed a bad route, a bad BGP route, right? And because there was so much capacity for network in so many different places globally, what happened was, if you can imagine like a map of all these connections of where packets could come in and go out of our network, as the route was propagating, they were just going dark, one after the other. But it took us a while to notice because we have fiber connecting all these things, and it's very fast, and there's so much capacity that the traffic was just being moved to other parts of the network, and you didn't see it in the latency, you didn't see it in sort of the characteristics you would expect. And we kind of didn't really feel the effect until essentially, it's a little bit of hyperbole, the last node went out. Like the last exit to the door closed, and then the whole flow stopped for a few minutes. That was a case,
Yes.
I think, where the redundancy and the defense in depth was good, but not necessarily accompanied by the right kind of monitoring.
Absolutely, and we've had variations of that outage at other times as well. I mean, the lesson is defense in depth is great, but you want to know when you start using other layers of your defense. And that was our problem here, is the particular monitoring in the scenario that Dave is talking about was not precise enough to tell us that individual locations were no longer attracting traffic. All we could tell, at that point in time, all our monitoring told us was that traffic was still getting through to the backends, until suddenly it wasn't.
Okay, George, you demurred to Steve when I asked you the question. I'm not letting you off the hook.
Can we tell more stories? Yeah, by all means. Because we got time and we got stories. I was going to say, like, this is a classic sort of set of failure modes. We had an interesting outage in a system we will not name, near outage, where our a configuration change was rolling out, which was at an upstream system, which we were mostly not aware of because we didn't need to know. But we got a low traffic alarm from one of our clusters. We monitor traffic levels, and these clusters are pretty busy, so when we didn't get any traffic in the cluster, that was cause for an alert to go off, and what's going on? Let's go look. Okay, there's no traffic. And as we're debugging that, trying to figure out what's wrong with that cluster, another alarm goes off in another cluster. And it's like, oh no. And now we are frantically debugging, because as we're watching our maps, we're watching traffic dropping offline in no order we can determine as traffic vanishes from front-end serving clusters. And at some point, somebody in the team made the connection that was following the exact pattern of the Google front end. It's one of our front end proxy systems, and its config push. So which happens to be one of Steve's teams. So we reached out in a panic and begged them to stop their push while we figured out what on earth had gone wrong. And sure enough, somebody who will not be named.
Blameless postmortems.
Had made a typo. Yeah, had made a typo in a config change, and it had been reviewed by numerous people, none of whom had spotted the typo. And so as the config went out, the front end conveniently forgot the particular back end in question and stopped sending traffic to it. And we halted it with one cluster left. Just one. And so we processed all of our global load on one cluster for 24 hours before we could get that corrected. This was quite a while ago. It was a lot harder to roll back those systems. These days we could roll back very quickly. In those days it was a bit more of a journey to achieve rollback. And so we decided it was actually safer to stay in place, because we were doing all right. It was running slower than it needed to, but it was functioning correctly. So we could hold out 24 hours until we could get a safe rollback. So much fun and games.
Both George and Steve, guys both mentioned postmortem culture. I don't know, maybe George, you want to elaborate on what that means for us?
I'm assuming everyone's read the books, so they know all about postmortem. No, I mean, this is sort of what we consider one of the key principles of site reliability engineering and just good reliability engineering in general. The idea that, like, if you're moving quickly, you're working on big, complicated systems. These large-scale distributed systems have emergent properties. Things are going to happen that you couldn't predict. Things are going to go wrong. People are going to make mistakes. And the ability and the willingness to go back and thoroughly understand what happened so you can determine how to prevent it happening again and learn from the outage is super important. But the only way you can have a culture which, that really does that is by endorsing that blameless part, right? Humans make mistakes. It's what we do. Humans are excellent at making mistakes. If you want something to not make a mistake, you use silicon. The problem is the silicon is programmed by humans, and what did I just say about humans? So we have to be willing to go in, no blame, it's going to happen, right? We're going to introduce bugs. Software engineers write bugs. We're quite good at that. Systems are going to fail in unexpected ways. If we're expecting humans to never make mistakes, you failed. Humans are going to make mistakes. If you've got a process that requires a human not to make a mistake, you're going to have an outage. And so sitting back and looking at that and understanding that is really important. And so you've got to have the blameless postmortem, the willingness to go back and look at it.
And on that note, one of the most important things, in my opinion at least, about a blameless postmortem culture is not blaming the human even in the actions. So when you're thinking about how do I avoid this problem, it is a mistake if you say the way I will avoid this problem is by just training the humans better, or by teaching the humans to do something more intelligent, or by updating the procedure that the human uses. Maybe you should do all of those things, but that's not actually a root cause. The way you should look at an outage and the postmortem about an outage is identify why the system allowed the human to make the mistake. You should fix the system so the human cannot do that.
Yeah, and I think there's a classic example of this from quite some time ago now. There was an outage in a webmail system where ultimately the trigger for the incident was a human. A human pushed a change. And the human in question, a friend of mine, was very upset. He had felt that he had personally caused an outage, a major outage that basically all of Google's users had experienced. But the reality is he was working through a change process to change. It was actually the contact management system to change the way the available backends for the contact management system and how they were served. And this system had got a lot more complicated. I mean, our systems scale very quickly. And so a process that kind of made sense when there were 2 or 3 nodes didn't really make nearly as much sense when there were 200 or 300. And so the process required a human to review a machine-readable data set and the diffs on it and make sure that it was correct. That was the control. Humans should review diff and approve it. This happens a couple of times a week. And you know what? 99.9% of the time there's nothing there. So of course the human looks at it, looks about right, moves on. Right? And we can sit back and we can say, hey, they should have been more careful. But that's ridiculous, right? It's the classic thing of 90% of the job is boring and, 1 second of absolute terror. It's when the thing is almost always right, except when it's not, humans are a terrible choice, right? Human mental pattern matching does not function in that environment. So the engineer did what every other engineer in their position would do, and they looked at the diff, it looks about right, off it went. And left that system with insufficient serving capacity, which triggered a cascading failure of that contact management system, which in turn caused severe consequences further up the stack. There's many problems here, right? A failure in a contact management system shouldn't prevent access to your email, but that process had not scaled with the system. And the idea that somehow this engineer was at fault is ridiculous, right? That outage was guaranteed the moment we put that process in place. Right, the fault there was not the humans. Didn't matter what human was at the keyboard that day. If it didn't happen that day, it would happen the day after. It could have happened the month before. That outage was inevitable. It's not the human. Human just happened to be the person on the keyboard. And so another example is really important to remember. We were asking a human to do something that humans are not good at. The failure was in the process and the technology. There should have been the machines should have been checking that. The machines should have been doing velocity checking, which is basically a technique where it's saying, this is the expected size of any change in this configuration. If it's larger than this, stop. But we didn't do that.
So you touched on something about looking at the assumptions of the system, right? And so that's one of the main things we do when we do disaster testing is challenge assumptions about systems, especially long-held assumptions about systems. So, maybe you have a backup, right? Well, we always back our data up. Of course it's good. Of course we can restore it. Why would there ever be a problem, right? So I would come along and I would say, we really should test that backup and restore, and we should look at the integrity of that data because your data isn't actually useful unless you can use it, right? So having a backup is just one thing. Being able to restore it and use it is another thing. And maybe failing over, right? I'm in multiple zones, multiple regions. Well, actually go and test your systems and drain a zone or whatnot, so that you can actually validate practically that these assumptions work correctly in different failure modes and different scenarios.
Yeah, I'm newer to Google. I haven't been there as long as you guys have. And I remember not long after I joined, someone was explaining to me blameless postmortem culture. And I was skeptical, right? Because I've worked in other companies, and the first thing you do is you blame someone. And I remember I had this conversation with George. I was in Seattle. And I said, that sounds good, but I don't kind of believe you. And he said, oh, really? And I don't remember who this was, and even if I did, I wouldn't use their name. He's like, come here. And he walked me over to someone, and he said, hi, this is Dave. He said, tell Dave, when were you last promoted? And the person told me it was been like 6 months ago. He said, why'd you get promoted? He said, well, I broke something. All right, well, that seems the opposite of the way that normally works. Please use more words. And he said, oh, well, what happened is I was doing a thing, and I made a mistake. I made a mistake, and I broke it. And that was bad. And then, of course, I fixed it. And then I wrote the postmortem. And then I built software so the system wouldn't allow the next unlucky person, who happened to be me, to break it the same way again. And it turned out to be a bunch more work than people thought it would be, because it was a complicated thing, because of a big emergent system. And lo and behold, the company was like, great, that is working as intended. Like, you just happened to be the unlucky person who made the mistake that someone was eventually going to make. You raised your hand, you fixed it, you led the process, you built the software. Now another person can't make that mistake again. You're promoted. And I just remember that was the thing that really sort of stuck with me, was that conversation.
I was actually going to come back, because I think a point John just made about there's an old adage in systems administration, right? Your backups are only as good as your restores. And one of the things that came out of one of John's dirt tests for one of my systems is we'd done a bunch of restore testing, and we knew we could restore. The restores were great. They worked fantastically. They're pretty quick. And then the dirt team showed up and said, okay, well, we know you can do account restores. Let's restore the entire system. And we were like, sure, no problem. Get the thing kicked off, get it running. It's running a bit slow. Estimated completion date, 2119. Not the time, the year. And it was like, oh, yeah, I mean, each individual restore was pretty quick, but we hadn't actually sat down and run the numbers. And it turns out, because of the way the storage system worked, and it was, random access and some other things, like the time between account restores was pretty long, and the result was we'd never tried to, we'd done individual restores and we'd done batch restores, but we'd never tried to restore a really big group. And that was the only time where we realized that actually, if we ever needed to do a complete restore, we were not going to be able to. And that was a result of, one of the folks that John works with coming to us and just saying, can you do this? And us, saying, of course we can. We'll test it. Okay, we'll test it. It'll be fun. So anyway, short story is we promptly rewrote our restore system to do a lot of our restores in parallel. Strangely enough, made a huge difference, and now restores much, 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 much faster. But I still remember the email coming across saying, yeah, no, we'll be done in about 200 years. I was going to say, there must be some funny stories that have come out of dirt tests.
That was the thing I was going to ask you, John, right? So you sit in kind of a privileged position, not only to see wacky things, but to cause them, to make them happen. So I'll give you a choice, fielder's choice. And then we're going to play a game of Topper, but I'll explain that in a second. So what is either the craziest thing you caused, either on purpose or not on purpose, or just the craziest thing you have seen as a part of doing dirt? I want to hear this.
That I can talk about, right?
That you can, yeah, right. Keeping in mind, we're in the middle of Google's semi-annual performance review season. Right. So you just want to hold that in the back of your head.
Right, of course, yeah. So I think probably a good story is, so I mentioned earlier that we have a company-wide disaster recovery test week event, right? So we're running several hundred tests over a week. A lot of them are very disruptive to ourselves, not to our customers, ideally. And this one particular cycle, we got about halfway through the week, and we're planning scenarios. We kind of have a story that goes along with it, right? Like maybe an asteroid is hitting the Bay Area, or maybe some storm is affecting the East Coast. So it turns out about halfway through the week, a large winter storm actually did occur and impact the southeast U.S., which wasn't great. Some places had reduced staffing, things like that. On top of that, on the West Coast, we had a real fiber cut that coincided. And so that was okay, that's fine, one fiber cut, no big deal. But then on the East Coast, in a totally separate data center, we had a network line card failure. And okay, fine, a little bit of additional latency, we're still okay. Let's get a card shipped out there and replaced. That card was dead on arrival. Now there's this winter storm. It now is going to take FedEx or UPS, whoever it was, an additional 2 days to get a line card. So now we're going to need to kind of recalibrate and say we're going to run with a bit of additional latency for longer than maybe we would have liked. But that's okay. We're still working through things. All right, we're still running our tests. We were running a test of one of our storage layers in one area, and nearby there was an unexpected power event that affected the storage layer that we were testing in a different location that sort of reduced their available capacity. So we're kind of like piling on with all these real situations. So, I think the thing that surprised me most was that, here we are planning these disasters and trying to do disaster testing, and all these real events are occurring at the same time, right? So sort of if you think it will happen kind of problem. So we paused our tests, we rolled back certain tests, and we totally changed the dynamic of our war room. So we took our room of experts, and instead of trying to cause issues, we started to help resolve the issues. So we helped with incident management. We helped, the teams that were directly trying to address some of these issues. We could do troubleshooting. We could actually fix some of the issues for some of them in some cases, and help get everything back together. So I think what surprised me is the way that, don't panic when disaster occurs, because it will occur. Keep a cool head, invoke your incident management protocols, lend a hand, and people were very creative and very supportive in helping get everything back up and running very quickly and very successfully. So, as someone who is trying to cause problems in a constructive way, it was very cool and surprising to see us actually pull together and fix things in a big way.
And being on the receiving end of a lot of that testing, I remember a couple of brainstorming sessions as we're getting ready for our annual testing, and we're sitting there saying, okay, well, let's work through our emergency procedures and figure out what we want to test this year. And I said, well, we test that one. Oh, yeah, we actually did that a month ago because it happened. Oh, yeah, okay. Well, no, we did that one recently too. Oh, actually, we've kind of tested everything so far in the last 6 months because everything's broken at some point or another. And we had to come up with some particularly creative and crazy tests because it was like, it turns out there's two types of emergency, right? There's routine emergencies and emergent emergencies, and we're pretty good at routine emergencies.
Yeah, I think you raise an interesting point too, which is that we like to look at the systems and test the systems and try to make them fault tolerant. But there's also humans involved, right? As you were talking about earlier. So practicing incident management is really important, right? Being able to quickly invoke people to respond to the incident, that they have muscle memory there is a big deal. A lot of times, like at Google, we have a very horizontal structure with people and management. So, when we have an incident, we tend to evoke this incident management protocol that's more hierarchical. Because the scenario calls for it, right? You need someone who can call the shots. You need people who are feeding them information. You need people to do communications and troubleshoot, and that needs to be able to expand or shrink depending on the scale of the disaster. And that's a little bit unusual for how we would run the day-to-day. And so practicing that over and over again and being prepared on the human side makes a huge difference. Ideally, your systems can self-heal and defend and things like that. But.
Yeah, Steve and I both sit on our sort of global technical incident response team dealing with sort of the largest events. But I remember it's a good couple of years ago now during DIRT, because DIRT, of course, is one of the most stressful times for the incident response team, because we want to make like this is real. But we're taking, events that in the real world, the narrative would span over a month maybe, and we compress it down to like 3 or 4 days. And I remember a couple of days that week where I was the incident commander for the global environment. And I think simultaneously I had 3 data centers on emergency power, 1 under simulated terrorist attack. The Bay Area was underwater, and something was going on in Europe. And yeah, so I mean, I just had my whiteboard just covered in like current status and runtimes of facilities, and I've got various operations leads running these individual incidents, so I try and keep track of it. And because of the simulated outage of headquarters, like I supposedly have no fallback to executives, and so it's just like, we'll keep production up as long as we can. But it was quite the test of our incident management capability.
I mean, the great thing about that is I never had that experience because I work in the Bay Area, and inevitably in Dirt Week, they tell us, oh, you're underwater, you're part of the disaster. So the rest of the world has to take over.
Yeah, I'm based in Seattle, so whenever that happens, everyone looks at me. And 1 or 2 of my colleagues on the East Coast.
Okay, I want to be mindful of time here. I want to wrap up with this. All right, so John, we heard from you. Steve, I want to know, what is either the strangest incident you have caused, Steve Cartensen have caused, or that you've been a part of that you can talk about? Oh, I mean, there are so many from which to choose.
I'm having a hard time right now. I mean, the edge node outage, our edge nodes are internally called satellites. So the edge node outage is known internally as Satpocalypse because it's when we destroyed all the satellites. But that was one of my favorite outages. I'm trying to think of another one that I can actually talk about. Sorry? That was actually before my time, sir. All right.
Let George go.
Let me think about it while George does his.
I was going to say, it wasn't an outage per se, but we had a particularly hilarious internal outage. So, much as, we have a pretty impressive infrastructure. We've got a lot of software engineers doing a lot of cool stuff, but we've got legacy systems too. To be fair, the company's only about 15 years old, so then, 20 years now. But so not that legacy, but we had one particular internal system within the ads environment where we stored session state for some front ends. Back when we thought that was a good idea. We don't. General rule of thumb, try to avoid session state if you ever can. But we had session state and we needed to flush it into the storage backends in order to ensure that session state would be retained if we had a fault. If there was a failure of a front end, we could keep session state on a different node. And this was ancient code. We have whole RPC environments now which handle internal communication, but this predates all of them. So it was a very primitive system, and we never really felt the need to upgrade it because it worked. And then one day, the nodes start failing on us, the session state service, and we can't figure out why. They're just falling over globally. Not all at once, but sequentially and just patterned down and just failing. And so we're all frantically looking because we're worried that it's working because these things are multiply redundant. Objects are getting passed between nodes, and so no user visible problems, but if we lose many more at once, because they restart quickly, we're going to have a problem. So we're all freaking out because we're trying to figure out what on earth is going wrong with these things before it worsens and we actually have an outage. And we discover they're all going out of memory, which is weird because they really don't do very much. And we dig through the logs, and we're having a heck of a time finding logs because guess what? You usually write logs when you're done writing a request. When done processing a request, if you crash while you're processing it, you don't always get a log entry. So we're frantically searching. We think we've got a query of death, right? Which is basically some combination of traffic at the front end is making its way through and knocking over any back end it hits. So we're trying to dump out traffic and figure out what's going on. And then we notice that when they go out of memory, they always request precisely the same amount of memory. So it's 4 gig or so RAM or whatever they were requesting, and it was taking them out of memory, and it was always exactly the same number. And it was suspicious. The number was not special in any way, except it was always the same. And so we're like, okay, clearly query of death, clearly query of death. We're digging around. We can't figure out what's going on. And the failure rate stabilized, and we can't figure out what's going on. And then an amazing intuitive leap, one of the engineers on the team just sits back in his chair and says something I won't repeat on live camera, and then just writes up on the board 4 dashes, and on top of them writes GET space. That was the ASCII encoding of the decimal number that was being allocated. And so what was happening is one of the early spiders in Google production was sweeping through production, connecting to ports, and sending a GET, as you do, because everything, most things at Google speak HTTP, unsurprisingly. Except these machines didn't. They ran a very primitive protocol, and the first 32 bits of the packet were the size of the object being allocated. So when you connected to that port and you said get slash, it interpreted the get space in decimal as the size of the object that followed. So of course the first thing it did was it tried to allocate that much memory, couldn't, failed. So we just sat around the room laughing our asses off for about half an hour before we pushed an emergency fix to, input check.
All right, Steve, you've had a reprieve. We've got like about a minute left.
All right. So there's too many to pick from, but this is a more recent event a year or two ago. And I pick it mostly because I was actually on call for this event. I'm on call. I got a huge passel of pages because one of an IP address that is used for domain resolution external to Google, one of our DNS VIPs, was being black holed, and all of our monitoring was alerting and saying horrible, horrible things. And so I get paged, I start frantically trying to debug, trying to figure out what's going on. I eventually figure out that the traffic is successfully coming into our backbone, is crossing our backbone, is getting to some of the locations where we host this IP address. We're looking, and then eventually we, through a chain that I can't really summarize, chain of events, one of my teammates and I figure out that what is actually happening is one of our internal systems that is a defense system to deal with DOS attacks has been enabled on this particular IP. And it's at that point that we discovered that this was actually a dirt test to see whether we would notice and how fast we would figure it out. Because it turns out that the way that this all works, this particular IP address was not actually important. Clients just seamlessly fail over to one of the other NS VIPs. And so the impact was 0, except to my heartbeat.
Your sanity, yeah.
Yeah. It was good times. We did figure it out in what, like 20 minutes? Yeah.
Okay, so on that note, a quick announcement. Remember, everyone, 5 o'clock this evening, happy hour here in the Fifth Nine Lounge for those of you who are in person and at the event. We'll be joined by Home Depot. They're going to have a bunch of really interesting things to say. But just this moment, please, a round of applause for our panelists, John Welsh, Steve Cartensen, and George Sadlier.